Hello! In this video, we are going to prove the following theorem. Suppose a, b, and c are real numbers, and a is greater than b. If c is greater than 0, then ca is greater than cb. And if c is less than 0, then ca is less than cb. Okay, now here are some facts we're going to use before we get into the proof. The first is that for every two real numbers, a and b, a minus b is greater than 0 if and only if a is greater than b. The second is for every two real numbers a and b, if a is greater than 0 and b is greater than 0, then a times b is greater than 0. And the third is that for every real number a, the negative of a is greater than 0 if and only if a is less than 0. Okay, so now let's get into the proof. Let's start out this proof by giving ourselves three arbitrary real numbers a, b, and c. And we are going to assume that a is greater than b. Now, before we prove both of these two statements, first I would like to note that a is greater than b implies that a minus b is greater than 0 by this first fact. Okay, so now let's prove the first statement. In the first statement, we're trying to prove if this is true, then this is true. So let's suppose that c is greater than 0. Our goal is to prove that ca is greater than cb. Now, since c is greater than 0 and a minus b is greater than 0, we can apply our second fact, which says if capital A is greater than 0 and capital B is greater than 0, then the product of capital A and capital B is greater than 0. So what this tells us is that the product of these two numbers is also greater than 0. However, we know that if we distribute the c across, this is equivalent to ca minus cb. So since c times a minus b is greater than 0, but c times a minus b is equal to this, it follows that this is greater than 0. And now we can go back to our first fact, which tells us capital A minus capital B is greater than 0 if and only if capital A is greater than capital B. So we can think of CA as our capital A and CB as our capital B. It follows that capital A is greater than capital B, which means CA is greater than CB in this case. And this is exactly what we wanted to prove in this first statement. So this completes the proof of 1. Now we're going to prove 2. In statement 2, we're trying to prove if this is true, then this is true. So let's suppose that this is true. Now, from our third fact, because c is less than 0, this means that the negative of c is greater than 0. So in this case, we see that the negative of c is greater than 0 and a minus b is greater than 0. Going back to fact number 2, it follows that the product of negative c and a minus b is also greater than 0. And then, if you distribute the negative c across this parentheses, you'll find that this is equivalent to cb minus ca. So, since the negative of c times a minus b is greater than 0, and the negative of c times a minus b is equal to this, it follows that this is greater than 0. And going back to our first fact, to say that cb minus ca is greater than 0 is equivalent to saying that cb is greater than ca. But we know that this is the same thing as saying ca is less than cb. And this is exactly what we wanted to prove in this second statement. So this completes the proof of the second statement. And we've proven everything in this theorem, so this completes the proof. And so yeah, that's pretty much it for this video.